Hello everybody, this is Shikha Sharma and I'm here to discuss the topic heat. Firstly, let us start what heat actually is. Heat is a form of energy that is transferred between two bodies or between adjacent part of a body as a result of temperature difference. Thus, heat, I can say it is a form of energy which is transferred due to difference in temperatures of the two bodies. For example, if I have a body A and another body B, body A is at temperature T1 and body B is at temperature T2. If I say that T2 is greater than T1, then the heat flow will take place from T2 to T1. Hence, heat is a form of energy which is transferred because of the temperature difference between the two bodies and takes place from the body at higher temperature to the body at lower temperature. Now let us consider how in which unit the heat is measured, that is units of heat. SI unit of heat energy is joule. Another unit to measure heat is termed as calorie. 1 calorie is equals to 4.18 joules. Thus, 1 calorie can be defined as amount of heat needed to increase the temperature of 1 gram of water from 14.5 degree centigrade to 15.5 degree centigrade at 1 atm pressure. Thus, the two main units of heat is joule and calorie. Now comes another important point which is known as specific heat. Now, specific heat of a substance is equal to heat gained or released by that substance to raise or fall its temperature by 1 degree centigrade for a unit mass of substance. If I say that heat gained or released by that substance is Q, then specific heat of substance is equal to heat gained or released by that substance to raise or fall its temperature by 1 degree centigrade. Its temperature by 1 degree centigrade. The gain or loss of heat, that is del Q, is directly proportional. First is directly proportional to the mass of the body. That is del Q is directly proportional to M. The second point will be rise or fall of temperature of the body. That is del Q is directly proportional to rise or fall of temperature of the body. That is delta Q is directly proportional to delta T. If I combine both the points, then I can write delta Q is directly proportional to M delta T. To remove the proportionality sign, I have to insert a constant which is equals to S M delta T. This S is known as specific heat of substance. S is equals to delta Q or Q upon M delta T. If I have to calculate the unit of specific heat, then it will be SI unit of S is joule per kg Kelvin. Joule upon kg into Kelvin, or it can be, that is CGS unit, erg upon gram into degree centigrade. Note, specific heat of water, which is mainly used in the numericals, is S is equals to 4200 joule per kg degree centigrade, or it can be 1000 calorie per kg degree centigrade, or it can be 1 kg 1 kilocalorie per kg degree centigrade. Okay, now there is another topic known as heat capacity. Heat capacity is also known as thermal capacity and is defined as the amount of heat required to raise the temperature of that body by 1 degree. If M is the mass of the substance and S is the specific heat, if M is the mass and S is the specific heat, then H is given as, that is heat capacity is given as, is equals to Ms. From this, the unit of heat capacity becomes is joule Kelvin inverse or calorie degree centigrade, or calorie upon. There are few points to remember in this. First point is that we know that S is equals to Q upon M delta T. If the substance undergoes the change of state which occurs at constant temperature, in state that occurs at constant temperature, that is delta T is equals to 0, then S gives me Q by 0. Hence S is equals to infinite. Thus the specific heat of a substance when it melts or boils at constant temperature is infinite. Second important point is that if the temperature of the substance changes without the transfer of heat, if the temperature of substance changes without the transfer of heat, then S is equals to Q upon M delta T is equals to 0, which occurs mainly in the case of thermos flask. Another topic is water equivalent. It is the amount of water which requires, it is the amount of water which requires the same amount of heat for the same temperature rise, which requires the same amount of heat for the same temperature rise as that of the object. Now let M is equals to mass of substance. Let M is equals to mass of substance with specific heat S. In order to obtain water equivalent, we can write the equation as Ms delta T is equals to Mw, that is mass of water, specific heat of water into delta T. M, mass of water into specific heat of water, is known as water equivalent. In calorie, if I say S of water, that is specific heat of water, is taken as 1. Therefore, mass of water is equals to Ms. From here I can write mass of water is equals to mass of substance into specific heat of substance upon specific heat of water. Mass of water is also represented as W. So W is equals to Ms. Unit of water equivalent is calorie upon degree centigrade or joule upon Kelvin. Now let us do one numerical. Calculate the amount of heat required. Calculate the amount of heat required to increase the temperature of 1 kg water by 20 degree centigrade. According to the formula, delta Q is equals to Ms delta theta. S I will take as 1 calorie per gram degree centigrade, or which is equals to 1 kilocalorie upon kg degree centigrade. Thus 1 into 20 is equals to 20 kilocalorie.